Hey you guys, alright, here's help for number one. Tricky little thing. When I assigned it, I didn't kind of look into the details of it. Let me start you off with, well, just the basics of the problem. Get you set up. Here it is. Something to the effect of x to the 1/2 plus x to the, or y to the 1/2 equals a constant. And the 2 points that you're given over here should be perfect squares. Makes this problem work. Now I'm going to go all the way to the end, let you kind of see this. If you guys want to just see the answer, there you have it. That's all of the work. Might want to pause this, take a look at it, get the idea. Oops, sorry, I didn't quite finish that. But that negative 7/5 ends up being the correct slope for this particular problem. But I do want to take 1 second to talk to you about some properties of exponents that ends up being key to this problem. So if I give you, first off, you have to know that the square root of x is the same thing as x to the 1/2. That's a big deal. Got to know that. The other one is you have to know that negative exponents, if you have x to the -1, that's equal to 1 over x. That means if you have a negative exponent, you move it to the other part of the fraction. And simultaneously, if I have, let's say, y to the -1 in the denominator, it's the same as y to the first in the numerator. So it basically means the negative exponent means flip it to the other part of the fraction. So knowing that, we are going to run into this situation in our problem, x to the -1 over y to the -1. That means we swap them both. That's the same as y over x. Now we end up with a different power of 1/2. So I might as well just cut to the chase. All right, x to the -1/2 will run into this over y to the -1/2. We're going to run into that. That's the same as y to the 1/2 on top over x to the 1/2 on the bottom. That is what drives the last part of this. And so now that you had that preface, I'm going to back up again and say, all right, let's take the derivative of this. Okay, so what we're going to do is take the derivative of both sides with respect to x, and what it means for the first term is that you get negative, or 1/2 comes out front to the -1/2 dx dx. Now, of course, that dx dx ends up canceling, so we'll get rid of that. 1/2 y to the -1/2 dy dx, and then, of course, the derivative of 12 on the other side is 0. Then we end up trying to get dy dx by itself. So I subtract the 1/2 x to the -1/2 from both sides. Here's what I get. Then I want to, then notice the 1/2s on both sides cancel. I'm going to divide by y to the -1/2. And notice just dividing both sides because y to the -1/2 is multiplied to dy dx. So I divide by it. Dy dx is by itself now. So good, we're ready to roll. That's a good looking derivative in there. The only thing is that exponent rule stuff I was just telling you about means we want to take those -1/2 powers. The y to the -1/2 moves to the numerator, x to the -1/2 moves to the denominator, the whole thing's still negative. Then we're going to put in the x and y coordinates in their appropriate place. And 1/2 power means square root, so that means -7 over +5. That's the end of the problem. I'll send you some help on the others as well.